All right, so now we're going to graph the other four functions itself, right? Tangent, cotangent, secant, and cosecant. Okay, these actually aren't that bad when it comes to it. All you have to do is remember that tangent in this case is y over x, right? So the y value over the x value. So we're going to graph the same process we did for the x, the sine and cosine portions, but we're going to break them into this parts here, right? So cut this in half. So this is going to be pi over 2, pi, and 3 pi over 2, and just go the opposite in the opposite direction, like that. Okay. And you'll see it really doesn't matter on the x value, so just go 1 and -1, but it really doesn't matter on the y values. All right, so here's a question for you guys. So if we go back to our unit circle, right, and just like we did for the cosine sine, we're just going to go all the way around the unit circle. So at 0, since tangent is y over x, what's I can do a y value divided by our x value. So what's 0 divided by 1? And you should get 0. Right? So our first point is just 0, 0. So it's tangent portion. And we do the same thing. We're just going to go around the unit circle itself. So 1/2 pi over 2. So y value, so 1 divided by 0 actually doesn't exist, right? It's undefined. And in fact, since it's undefined, we actually have a vertical asymptote at that portion because it's undefined. Okay, let's keep going. Pi. So 0 divided by -1, still 0. Right? So that's there. And then 3 pi over 2 down here. So -1 divided by 0, same process, right? It's undefined, which means we have a vertical asymptote. And believe it or not, going the opposite direction gives you the exact same process. So the question is tangent just 3 points? Actually, no, right? So if we go actually from, let's say, from 0 to pi over 2. So from 0 to pi over 2, this portion is half a circle. Let's see what's happening. So if I just divide these numbers itself, right? So it's y over this portion, y over x, y over x, y over x. You actually get larger and larger and larger, which means this on this side it goes up to here, believe it or not. Okay. On the alternative, if you go this way, and if you divide this number by that number, right, y over x, you actually get really small, a bigger negative. So therefore, on this side, you're going down here. And that's actually the graph of tangent. It just repeats itself in that same process. So it's kind of like the Q function itself. It just repeats and repeats and repeats in both directions. Okay. So because of this, we have a couple of properties to deal with. Okay, so our domain is all real numbers except where we have a vertical asymptote. So odd multiples of pi over 2. Okay. And what I mean by odd is, right, there's a 1, 1's odd, 3's odd, so in other words 5, 7, 9, all the odd pi over 2s actually become, so in other words, the nice even numbers end up being nice, like 2 pi is good, 3 pi, and so forth, right? Those are the even numbers, multiples of those. Okay. Number 2, the range is all real numbers. So this goes to infinity, this goes to negative here, so it includes all of the y values inclusive. 3, this is an odd function. And 4, the period is pi, right? Because it goes 1 whole revolution. This is half a circle. This is another half a circle. Put them together, you get kind of like a whole circle. So it's literally just pi portion, right? From here to here is just a pi. From here to here is just a difference of pi. Okay, so if you flip the page, let's do the rest of them. So the next one is the opposite of tangent is cotangent, right? So now it's x over y instead of y over x, which doesn't change too much at all, believe it or not. Okay. So remember, this is x over y now. So if we go back to our unit circle, well, here's 0, 0, right? So x over y. So what is 1 divided by 0? Undefined. So just like last one, this is actually vertical asymptote. Oh, this might be the opposite now. So going over here, remember it's x over y. So 0 divided by 1, this is now 0. At pi, this is negative 1 divided by 0, again is undefined, which means we have another vertical asymptote. And the same process goes on the other hand, just like that. Okay? And again, believe it or not, since they're complete opposites of tangent, well, it reverses the process. So this side, it goes up this way, and the other side goes down that way. So literally, it's the complete opposite of the tangent function, right? So the tangent function did this, right, going from left to right, going increasing. This one's going the opposite. It is decreasing from left to right. Okay. Ooh, focus. There we go. Okay. So same thing when it comes to a couple properties. It's almost identically when it comes to tangent. So the domain is all real numbers except multiples, and now this time pi. Right, so 2 pi, pi, 3 pi, 4 pi, 5 pi, all are undefined because it's when it comes to that. 2, the range is the same, all real numbers. Okay. 3, it is odd function. And 4, just like tangent, the period is also pi. Okay. So that is cotangent. Okay. Now, the next graph is cosecant and secant. Now, believe it or not, these actually are the easiest of the graphs when it comes to it. So what we're going to do is, remember, right, what is cosecant? That is equal to 1 over sine, right? So what we're going to do is we're just going to graph sine function itself. So from negative pi over 2, so negative 2 pi to positive 2 pi. Okay. So remember, this is it's cosecant, right? So this is sines. We're going to graph these sine function because they're opposites of each other. So the sine function looks like this. Okay, so there's our sine function. Okay, so now, because it's 1 over sine, therefore every time it touches the x-axis, it's a 0. So just like the way we do for sines and cosines, so in this case we get 0, but what's 1 over 0 is undefined, just like we did above. So since it's undefined, we have, when it comes to the secant function, vertical asymptotes at exactly where it crosses the x-axis, like this. Okay. So that's the first step to graph the secant function. And now, believe it or not, because it's the, just like tangent is with cotangent, is the complete opposite. So if I just look, let's say here, this portion right there. Well, what's the opposite? Meaning, what's the opposite direction it's going at this point here? So in other words, from here to here, it's going down. So the opposite would be going up. Oh, from here, well, instead of going down again, the opposite would be going up. And believe it or not, that's actually how you graph the secant function for every interval itself. So for instance here, Since it's going up, this will go down. Since it's going up, this will go down. And this is going down, that means this will go up. And that's how you graph the secant function. So the secant function is only the ones that are in pink. Everything else is just to help you graph the secants. That's the easiest way I can think of when it comes to graphing secants. You literally just graph the sine function and make u's and just erase everything else when it comes to it. Pretty cool, huh? Okay. So next up, just quickly find domain. So it's everywhere except multiples of pi. Range is kind of funky. The range is the absolute value of y must be greater or equal to 1. So notice it doesn't go below 1 or negative 1. So that's why it's the absolute value. Okay? Or in other words, it has to be bigger than 1 or less than negative 1. That's another way to say that. Okay. Still odd function, right? Because it's still sine. And lastly, the period of cosecant is actually pi, believe it or not. Okay. So now, when it comes to the last one, secant is, guess what? We're going to literally do the exact same thing we did above, but now we're using tangent instead. Right, so this is secant, so now we're going to graph cosine. So to graph cosine, just quickly draw these out. Okay. All right, so now that we have that going, so now, just like the other one, right, the secant is 1 over sine. So again, everywhere you see a 0 is going to be a vertical asymptote. So just like the last case. And then guess what? We do the exact same thing we did above. Since it's the opposite, literally just look at this interval. Since the graph is going down, right, looping down, therefore the opposite would look looping up. And we do the exact same thing for every other interval. Like that. And there's your graph for secant. Okay. And lastly, domain is again everywhere except multiples of pi over 2. Range is the same as above. Absolute value of y is greater than 1. So again, it has to be bigger than 1 and less than negative 1, right, when it comes to it. 3, it is even. And lastly, period. Actually, so, my mistake. This is odd, I believe. So this is odd. And then period is pi. Okay. So those are the graphs of the other trig functions themselves.